Okay, we are recording. Hello to everyone who's watching the recording. Please say hi to the people who are... Wait, no, other way around. People who are here live, say hi to the people who are watching the recording. Today is the second day this week that there was a blog post on Hacker News that mentioned Zig, and then one of the dominating topics was about unused variables. And which makes sense because it's controversial. It's a controversial compile error that Zig has. So right now, if you have an unused variable, and let me just show you what my experience looks like. Wrong directory. If I have an unused variable, so for example, if I uncomment these and I hit save, I'll get an error, and it'll tell me that I didn't use this. And if I want that to go away, then I need to fix my code to not have unused variables, or I need to basically annotate that I'm intentionally not using it right here. Now, full disclosure, I love this feature. I was the one who decided to just strong arm it into the compiler. For me, I like it because when I'm refactoring a large code base, it makes it very easy to understand what I forgot to do when I'm cutting and pasting code. But when you're writing new code, I mean, as you can see, when I opened this file up, it looked like this, right? Why are these two things commented out? Well, because I used to use that variable, and then I deleted it from here because I fixed this function to not need an allocator. And then when I hit save, I got this error. I mean, arguably, I should have just deleted these lines, but whatever. Anyway, so that's the topic. Now, it's a very divisive topic. Some people love it. Some people hate it. Now, the easy knee-jerk suggestion is to have a compile flag for it, like a sloppy mode, right? You just say sloppy mode. Okay, here's the problem with that. The problem is that there's two categories of people. There's people who are happy with never having unused variables because that means that when they read code, they can assume that all variables are used, and that is nice to assume when you're reading code. It's a handy premise, is that all Zig code, even if I wrote it or if someone else wrote it, does not have unused variables. It's nice to know that. That's camp one. Camp two is I'm annoyed. I'm just trying to write code, and it's just annoying me when this happens. It's just getting in my way. It's slowing me down. That's camp two. Both valid positions to have. Now, the problem with a sloppy compiler mode flag is that it doesn't satisfy both camps. It seems like it does, but it doesn't, because if you have sloppy mode on, then you write the code, the compiler accepts the code, and then someone else who is in the other camp wants to read your code, they now have to use sloppy mode too, because the code is committed to the source repository using the sloppy flag. So there you go. It doesn't satisfy both camps. That's the problem. So here is the experimental idea that I want to do, and because I'm the boss, I get to just do it, and this is what we're going to do. And I'm happy to have people give criticism, but I want you to try it first. Try, what does that phrase go? It's like try before you taste before you hate it or something. I forget what it's called. But okay, I'm going to code something up. It's an interesting idea. Give it a shot. Okay, then you can say you hate it, and that's fine. Don't knock it till you try it. Thank you. That's what I was. Try before you. No, it's not this one. It's this one. Don't knock it till you try it. Okay, that's what I'm trying to say. Don't knock it till you try it. So here's what we're going to do. I'm going to add a flag to the compiler, but it's not sloppy mode. It's fix my code for me. It's auto fix. So we're going to do zig, blah, 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 auto fix. This is the idea right here. We're going to add this. Now, what this is going to do is it will automatically go in your code. So let's say that I had that same problem as before. Crap, I got rid of it already. Let's just say I did this. Okay, so then we get this error, right? If you have the autofix on, okay, we gotta turn that off for a second. But let's say that I have that. So there's my file. And if you have autofix on, then you do this, okay? And then it does build your code, and it does not give you an error, and it does not give you a warning, but then it will edit your code on disk, and your code will now look like this. That's it. That's the whole feature. Autofix. Don't kill the cow. You try the milk. Oh man. That's the whole idea. And now this is my argument for why this is a good idea. Because it does actually satisfy both camps. Because, okay, remember what the two camps are. Camp 1 is I never want to turn this feature on, and I want all code that I read to satisfy this property that all variables are used. Now, camp 1 is satisfied because their coworkers who are in the other camp, this is the code they're committing to the repository. And this is the code that's showing up in the code review. The code review reveals the unused variables, okay? But the other camp is also satisfied because remember the other camp is I just don't want to be bothered by this error. Just let me go faster. Just let me prototype faster. And that camp is also satisfied because you just run the build, it succeeds, your code gets edited, and it's fine. And like, who cares? Yeah, that's in there. Now I can delete it if I want. That's it. That's the whole idea. Feels like half a feature without it being a compile error to use a variable that is marked as used. No, don't worry, that's coming too. So the other half of this is if later we, I don't know, it's hard to contrive the code, but let's just say that I used it down here. You're going to get a compile error that says pointless discard. That's the plan. So if you have the autofix mode on, you'll never get this error either. It will just delete it. Same thing. So you get the experience, no matter which camp you're in, you get the experience that you want. You never have to read code that has unused variables. And if you choose to be in the other camp with the flag, then you never have to write code that deals with the possible error that you might get. It seems strange for a compiler to modify source code, though, doesn't it? Well, that's why I said that it's an unusual, unique solution. And are there downsides? If you can think of any, let me know. This might delete a lot of code that you still want to use. In Go, I've had the problem that I comment something out to track down a bug, which causes a cascade of vars being unused, even though it's important code. Well, it's not going to delete your code. It's just going to add lines of code and then delete those. It's basically automatically adding, like, have you ever used a lint and you can do like, silence, unused or something like this? It's just basically adding a lint for you and removing a lint for you. And so, but the difference is that the lint silencing has to be in the source code so that people who don't want to participate in the linting disabling flags are still getting that experience. Yeah, advent of code is where a lot of people run into this problem because you're creating new code and you're not maintaining a large code base. This feature is mainly designed so that when you're maintaining a large code base, it helps you. It's not going to delete any code that actually does something for you. Don't worry. Yeah. So autofix is going to fix trivial errors. So autofix will also, for example, change if you do like a hard tab and then on one line and you do spaces on another line, like autofix will fix this one for you, like that. if you do like this, normally you're going to get, you know, error, pointless discard a bunch of times, and autofix would get rid of these. So, yeah. Okay. So, enough discussion. Here's my ask. I'm going to implement this right now. We're going to see how far we can get. Try it out. Give it a solid try. Open your mind, give it a try. And if you hate it, let's talk about it. But try it. That's all I'm asking. Okay. So let's try and do this. Now, where am I here? Okay, this is where I work on Zig. I need another window for text editor. You know what? Let's use the same terminal. We'll use tabs like this. I want this one here. Okay. Well, okay, so you're saying fix unused, but it's going to fix things beyond, it's going to, am I currently recording? Yeah, I am recording. I almost broke it too. It's going to fix more things than just unused variables. Autofix is going to have other, there's other trivial problems that maybe you want to ignore when you're going fast, and it's going to affect those as well. So it's a more general purpose tool than just for unused variables. I'm thinking bigger here. I'm not only trying to solve one problem. Yeah, this is another point. Adding this autofix label is a pretty reasonable idea. I think that might be a good way to go. But okay, at this point, here's what I'm going to do. I'm going to make a proof of concept. I'm going to push it to master branch. You can all try it, see what you think, and then let's have some constructive criticism. Okay. Well, first things first, let's create a test case. So I guess let me just go simplify this one. There it is. Done. So what we want to happen is this. Okay, first I guess we better build the compiler. 4 LVM. You know what? We don't even need to use LVM in this stream today. I'm pretty sure. Let's try to get away with not using it. We might have to switch, but let's try. Install lib files. I think that's it. Okay, so let's time this too. Let's see how long this takes. I think this is going to be about 40 seconds, maybe. Okay. So that'll be our build for the compiler. Then we can try running this command. Okay, next we're going to need to add this command line flag. Now, we're also going to add it to zig build, but first, let's do command line. And yeah, feel free to interrupt with Q&A. I'm happy to just chat and shoot the shit and stuff. So I'm happy to answer questions like this. How did you get started learning how to build something like Zig? I've just been doing programming as a hobby since I was a teenager. And so, I don't know, when you spend enough time just exploring, you just sort of pick up the skills, you know? I mean, at this point, I'm 33, and I've been programming since I was 12. So I just put my time in, you know? Just like anyone who can play musical instruments very well, they just practice a lot. That's all. Okay, let's move on. So command line, let's go add the command line argument. I know that there is this function here that does all the command line argument parsing. Let's go find a good place to put it. It's just a flag, so let's go find some other flags. Well, now we can do this command here. Unrecognized parameter. Okay. It's a compile option. So let's put it next to Ooh, should we use the F prefix maybe? Now we're going to put it next to strip. Yeah, this is a fair question. The point of adding it as a compiler flag is that I can grant it first class citizen as, you know, it really does just let you build your project and fix it at the same time. And that way it can take advantage of the pipeline that does things on multiple threads. Like when we start digging into the code here, it'll make sense why this is a nice place to put it. So I hope that will become more obvious as we go in here. I need to word this carefully, the short help text for this. Avoid some errors by allowing Zig to edit your code. I think that's maybe the best way I can explain it in just the amount of space that I have here. Seems pretty reasonable. 10x mode. Just kidding. No, it will also delete code sometimes. So as an example, in the example we were looking at, given this code, it would add a line to fix it. But then if later you were to do, you know, something down here, and you end up using this symbol, then it would delete this line right here. So it's not just adding lines. It will delete lines sometimes. But it would not delete any kind of functionality. Okay. Yeah, I think that's a nice name. So let's now look for strip. That's where little flags can go. And then we're going to pass it into compilation right here. Yeah. Okay, that's it for main. Oh, I don't have the ability to use my... I guess I can use this one. Kind of like that, though. I think that's fine. It's useless after all. What are you talking about, Zoomagoo? You got an opinion you want to share? Do you have a explanation for your opinion or just an opinion? The compiler can't know if that line has side effects. Yes, it can. It knows that this line does not have side effects. Sometimes I'm just mucking around. Compiling with sloppy lets me do that. Once I reach my desired solution, I can turn off sloppy and see what I need to clean up. Okay. So your use case is that you do a bunch of edits, and then the problem is that you think that you may have messed up, and actually you do have some unused variables that are incorrect, and you want those to be deleted. Autofix just silences all code that needs cleaning. Well, then why don't you just not use autofix? So are you telling me that you want to use... Okay, so this is the... Okay. Here's what I think is happening here. I was discussing this with Loris earlier. There's two use cases in Camp 2. Use case number 1 is the one that Zoomga is talking about. And the use case is you have some code, you want to go sloppy for a bit, and you edit, you do a bunch of stuff, but you end up with like a pretty small diff, relatively. And now you actually do want to go audit all the places that you introduced unused variables. That's the use case that Zoomga is talking about. But there's another use case, though, which is that you turn this feature on because you're going to have unused variables, and then you write 10,000 lines of new code, and then you're done. All those unused stuff is actually correct, and you want to leave it, and you don't want to audit it. That's another use case. And I think that sometimes it's easier to just think of these use cases separately when we're trying to figure out the trade-offs of these things. Okay. I gotta turn off my phone. I got some beeps and boops over here. Not sure why I don't have it in I have it on Do Not Disturb, but I don't have it on silence, and people who are important to me are texting me. Okay, silenced. All right. What are we going to do here? Okay, so we have the create function. Where's strip? There it is. Ooh, what about the cache? Cache does not care about this feature. Auto fix. Also, bin file doesn't care about this. Only the compilation cares about this. Okay, I'm happy to discuss a little bit more, but I do want to go into implementation here. I'm going to do this implementation, and then we're going to play with it. So we can keep discussing it, but I also want to focus on the implementation. That's fair. Now, a bunch of people have suggested this. I think this is a pretty reasonable idea. Idea being that the autofix lines added for unused variables could just annotate when that happens. So example is like autofix, something like this. Very simple. And that's it. It wouldn't mean anything special. It would just be a comment. And that way, when you're looking at the code, you just know why that was added. And if you want to go clean it up, you can. Or if you want to leave it, you can. That's the idea. I think that's a pretty good idea. That might be what we start with. I gotta tell you though, I just like to code with this feature off. Even if I was writing new code, I like to have unused variable errors. It's hard for me to, I will admit, it is hard for me to empathize with people who want unused variable errors, but only sometimes. That I have to admit, it's hard for me to wrap my head around that use case, but I recognize it. I recognize that use case. Okay, well, we've now managed to populate this flag, and now let's go find the place. Where I'm thinking about doing this change. Okay. Now, this is an interesting function because it is run on a thread pool before semantic analysis. So we have to keep that in mind. Now we can read this Boolean flag without worrying about it, because at that point it becomes read only, and we could just look at it. So this is the function where we take a file, as in a .zig file, and we create we parse it, we tokenize it, we parse it, that sort of thing. So this is also the place where we learn that there's an error, such as a unused variable error. So let's go find where the errors are noted. There it is. So here we're checking for syntax errors, I think, actually. No. Why is it called tree? It is called tree. These are parse errors. Yeah, parse failure. Okay. Here we go. Now this is where we have a ZIR error. Oh, I know what's going on here. We don't have to check for errors here normally, because they're just in here. And then if you load the file, then we look at them. So we're going to introduce looking at this and dealing with errors potentially. So this is where we cache. This is where we read from the cache. Now, I don't think we have to care about it if it's cached. I think we have to care about it if it's uncached, which is here. I think this is where we care about it. Right. So, okay. I think this is a good message this is the thing to point out. It seems like people just want a sloppy mode flag, right? And yeah, I've also seen this suggestion before too. Make it force debug. Here's the problem though. If we do this, then I promise you that sloppy code will make it into source control. And then, like, has anyone here worked at Microsoft? Guess what? They have assertions in their code, but none of their code works if you turn on assertions. Like, you can't do that, right? So I'm trying to come up with a way where sloppy code doesn't go into source control. I will die on that hill. I will not allow sloppy code to go into source control. That's the point. Yeah, that's on topic too. I'm not even joking. Like I can tell you that my story is true. Why do I think it's the compiler's job to force people to program properly? People are either sloppy programmers or they're not. No tool will save them. Well, here's the thing. I'm making a new programming language, and I just don't want to read sloppy Zig code because it makes me upset, and I don't want to be upset. And I have the power to not be upset by forcing other people to not write sloppy code. So I'm going to exercise that power because it makes me happy. That's my logic. I don't want to look at mismatched tabs and spaces when I'm reading other people's code, and I don't want to look at unused variables when I'm looking at other people's code. I don't want to do it. And I want other people like me to also have the pleasure of having Zig code that they look at, even that's written by other people, at least just have some basic guarantees about what's true about it. And that's my hottest take. Okay, so let's try. It's too hot. I can't do the implementation with all these hot takes. Okay. So I think I need to go look at the ZIR, find the errors, and then see if we can possibly fix them. Let me just type out a comment here. If do we have comp in scope? There it is. If comp dot, see, like even right now, I know that this variable is the one I want it to be. You know why? Because there's no shadowing. And that's just a rule that I made up. And that just means that this thing is always what I think it is. It's great. I never have to go, like, obviously never is a strong word, but I feel like I can just I can reason with a small amount of locality, and it makes me very productive. Okay, so let me make a little bit of progress, and then I'll go through the messages again. So if the flag's not on, we don't have to do extra work. We can just move on. If the flag is on, then we need to look for errors. Okay, how do we do that? Compile errors. If this is 0, no compile errors. Okay, let's go find where compile errors are dealt with. Oops. Yeah, I'm getting a little thrown off with having the... You know what? It's bothering me too much. I'm going to pop this one out. There we go. So I can use my normal keyboard shortcut for navigating Vim tabs here. Okay. I want to find where we use this. Has compile errors. Must be here somewhere. Okay, here it is. What is that @ syntax? That is, it just means a function that is provided by the language rather than userland. Yeah, you know what? Look, I promise that after I implement this and you try it out, if you want to criticize it, I will have an open mind. I promise that. Okay, so if autofix is on and there are compile errors, let's try to autofix it. Okay, this is the hard part. Oh, I know where this is going to be. This is going to be in... we have to come up with an encoding for these compile errors. Okay, so compile errors payload. Oh, okay, here we go. So here's compile errors. Null terminated string index, node, token, byte offset, notes, message. Okay. Okay, I see how to get these. I think the example code's going to be in get all errors, maybe? Get all errors. There it is. Failed files. Must be ZIR errors. Here we go. Okay, this is our example code to look at. Payload index. I love how copy pastable zig code is. I mean, look at this. I just grab this code from here, and then look at this. I save. I know that nothing's unused and that nothing is referencing something that it doesn't use. And look at that. It's great. It's working perfectly. Okay, so then we grab this. I think we want a pretty similar loop here. So we have this thingy, items, len, extra index, edit my. Okay, then we get this thing. Okay, that's our iterator basically. Okay, so let's see if we can just, how are we gonna test this? Oh, okay, I know. We need to put one more check in here to see if the file is part of the root package. Oh. I was already checking this. Interesting. I think we can leave that. Okay, I want to make sure that the file, we only want autofix to affect the main package, not the like standard library package. Or just some like third party package that you're using. So let's figure out where we can do that. Here we go. Okay. What about root package? Oh, there it is. Okay. Wait, we also have main package? Okay. Normally, main package and root package are the same. The exception is a test, in which root package is the test runner and main package is user source. Okay, so we want main package. And mod main package equals file.package. Nice. I love that I can just guess the name of something that's in scope and save, and then if I'm wrong, I'll get an error. Okay, so now we've limited it to only files that's like the users, and they have errors. Now we're going to inspect the errors and see what they are. And let's just print them for now. We're not going to look at notes. And then where's the message coming from? Here we go. Wait, where's the... Oh, there it is. Okay, I think we can run this and see what happens. So let's review what we've done here. We added a new command line parameter, one little block of code here, and then it should, we're just trying to see if we managed to successfully extract out the compile error. Okay, let's try it on our example. Well, I need to recompile the compiler, obviously, so let's do that. There, about 40 seconds. Won't that check only work for the root file? It will work for the main package. I'm not sure why you think it will only work for the root file. It's checking if the file's package. So there was multiple files in a package, and we're looking at like the owning package. Okay, no field named autofix instruct. Oh, I remember what I used to do. Yeah, there we go. That's the move. Wait. There we go. There. Okay. A little cramped for space, but we'll make it work. There. No field named autofix in struct init options. Oops. Well, I already had a directory called stage 3, so there we go. In theory, they should be identical, but, well, we're changing this one, right? And we're not changing this one, so there you go. Yeah, I just like to reserve stage 4 for only myself. Just kidding. Big Zig doesn't want you to know about stage 4. Oh, man. Okay, well, that one built, so let's see what happens. Now, we do have to care about caching right now, because the way caching normally works is that you can have multiple versions of Zig, and it doesn't mess up the cache, because whenever you use the caching system, it uses this value as kind of like a namespace in the cache. But the thing is, we're editing the code without changing the commit number or the version number. So we do need to clear the cache if we want to test our changes to this. So I have a little, let's do that then. Here's my little cache cleaning script. There. Now let's do, all right, let's try our little thing. Now I'm hoping that we get that debug print that we added. Oh, look at that. Boom. So that's the official error, and then this is the kind of the preview that we got, where we can respond to it and try to stop it in its tracks. Okay, great. So far, so good. We're actually on a roll. So that means that these 3 conditions were true. And now we can try and do the auto fix and then try again. Okay, now I want to address something. So I did mention Hacker News earlier on the stream. I mean, because people are talking about this right now, so I just thought I could get some like extra viewers on Twitch, maybe. But I've had my eye on this feature for a while. I've had this idea for, I don't know, 6 months at this point or more. It's just, the thing is, ideas aren't enough. You have to actually go implement your idea before it matters, and that's fair enough. Oh shit, I spilled some tea on my keyboard. All right, we all good. Oh man. All right, keyboard's fine. Everything's great. It was thirsty. Wanted to taste the golden monkey. Okay, so I said this was the hard part, but now is the hard part. We found an error. Now, here's the thing. Okay, this is the information we have. I'm probably going to add a new field here in order to just like category, something like this. And this will just be like an enum that categorizes it as like unused local, or, like auto fixing crap, whatever. It doesn't matter. But for now, to simplify the stream, I'm just going to use the message, and we're just going to do a string equality. But we can improve that later by just adding more data to the encoding. But for now, let's just detect it literally with a string match. So let's just do an if mem.equal message unused local constant, and we'll just hard code for everything. Now, the big question here is the byte offset node and token going to be enough? I think so, because look, it's pointing at the, it's pointing right here, which is ideal. That's actually great. Or you know what? No, it's not ideal. We want it to point. No, it is fine, actually. It is fine. Yeah. Here's why it's fine. Because in this case, the auto fix is adding a new line. And so all we have to do is just keep going forwards until we see, sorry, not a line, but another statement. So we just got to keep going forward until we see a semicolon. And then we'll have some logic for, oh, we don't even have to care about that because we're going to run this stuff through Zig format. Does autofix alter source code? Okay, Tired Beaver, I want to ask you a question. You're asking if it alters source code. What is a different flag instead of autofix that would answer that question affirmatively, so that you're not even have to wonder? And also, it has to be a flag that lazy people are willing to type, because let's be honest, if you use this feature, you're lazy. Alter is pretty good. Here's a thought. What happens if the user the compiler is running as doesn't have write permissions to the file? Well, here's a counter thought. Under what circumstances would that be true? And under those circumstances, would it ever make sense to turn on this flag? The answer is no. Like on the CI, for example, right? This is my point. On the CI, you don't have autofix on. But it's fine because the autofix makes the code valid for the CI. Okay, anyway, so to fix this, we don't even have to care about lines because it's going to go through Zig format. So all we have to do is go in and add, after this, find the next semicolon after this token. No, it's an expression, so we have to care about the node. Right, so actually it would be ideal if the node was like the whole thing and not just in here. So that is maybe not enough information for us to do the work. I'll have to think about this for a second. Okay, let's take a look at our code again, knowing a little bit more, having thought ahead a little bit. Okay, so we get to here. We're going to take this debugging thing out, but for now, I'm going to leave it in there. Yeah, this is what I was thinking. How are we going to make this change? Let's say that we have all the information we need and we know what edits we need to make. Then what are we going to do? Let's just think ahead a little bit, and then we'll come back to that other problem. Okay. In this case, yeah, we have the node token byte offset. We know we want to insert a line. Let's say that we even have the identifier name. And we'll come back and, figure out what that is later. Okay, what are we going to do? So this is like, in this example, it would be mem. So we're going to need to go back to, to the beginning of this function. So I think we need to hook into the rendering code. And then we just basically repeat the function. Okay, so let's figure out how we're gonna call render. This code is in main. Tree.render. Okay, so we need. Okay, so it's AST that has a render function. ASTs know how to render themselves. Okay, so here's the question: can we edit the AST? That would solve the problem. It might be tricky, but we can try. So we edit the AST, we render it to the file, and then if that succeeds, then we retry AST gen. And then everything's good. I think that's the move. Rectify. Okay, so the render function takes a memory allocator that's just used temporarily, and then oh wow, render to array list. That's interesting. But we gotta, no, we're actually gonna do it. Oh yeah, it does go to an array list. Okay, that's fine. So we already have it in memory, and then we write it, and if that succeeds, then we move on. Iron. This is kind of funny considering the existence of Rust. Gently scrub. Updated and ruin. Oh yeah, that's so funny. Okay, I think we're seeing some puzzle pieces here. We just got to make them all fit. Unfortunately, I think we will need to add more information to the compile errors. That's fine. So maybe we'll just have another field here that's like, I don't know, it's just the information that's needed for a autofix. Yeah, that's fine. Maybe ASTgen could even just, well, meh. Okay, anyway, let's get back to this. I think we're close to having something interesting happening. We just need to connect all the puzzle piece edges to each other. I think I see all three. There's 3 problems to solve. Let's just pick one and start solving it. Okay, so we found the unused local constant. Next, we need to extract the identifier name because we need to insert after the expression. Variable declaration. Okay. This could be a pretty reasonable feature. I could see this happening. I think for starters, we wouldn't add this, but then once we kind of stabilize, then we decide whether to add this. Yeah. This is pretty good. A bit long, though. A bit long. Yeah. Apologize. Repent. Okay, can we get the identifier name? Yes, that's the one that it's actually pointing at. So in this case, I'm going to pull up another one of these. There it is. How do we get the token name? Here we go. Oh, we have the byte offset. Oh, but we don't have the token end. Note item. No. We need item. Item. What's this? Okay, so we have the start, we have the end. Token slice. Ident name is, where's the bytes of the file? Is it called source? Yep. Is it called tree? Okay. File.tree.source, start, end. Boom. Found unused local constant. Okay, there we go. Question, did we solve one of our 3 problems? Oh, you know what it should be? I know what it should be. It should be dash dash and then the see no evil monkey emoji. That's what it should be. We're about to learn who has the quickest draw on the emoji keyboard, and it's Dead Robot Dev. Way to go. Okay, so let's do this little clear, and then okay, so that's one problem solved. That's kind of funny, actually, even though I hate the corporate vibe. That's actually pretty good. Okay, so we found unused local constant mem. Let's try to fix it up now. Okay, problem is the node that we have pointed at is, well, actually, you know what? What is the node in this case? Pund error toke. Oh. We don't have a node. We just have a token. What's the node in this case? We just passed 0. That's brilliant. You know why? Because it means it's an unused field, which means I can just start using it without changing the data layout. Oh, okay. Okay. That means everywhere else just assumes that it's only the token's valid and the node's not valid, which means I can use the node. Let's go. Okay, is this the only unused? I think it is. Amazing. Let's just try something. We're back. Amazing. Okay, we're actually doing great. So I'm going to change this to append error token node. We're just making stuff up now. Let's go. So we're going to pass in the token. Now, I want to pass in the node of the entire variable declaration, not the node of this. I want the whole thing so that I can go after it. Okay. All right, what is this S thing here? Scope. Some scope. Token source. Oh, I see. We are only storing the token. Okay, we might need to store the node too. Okay. I think if because this is zig, I can just follow the red brick road. And here's how. All I gotta do is this. Okay, obviously I gotta go make this function now. Okay, then okay, let's see if the compile errors. See ya, Jacob. Have a good night. Wow, you're up late. Sorry to keep you up. Let's see if the compile errors lead me towards a solution. Okay, I was hoping it would compile a little faster than this. Oh, I know why it's doing this. It figures out these errors pretty fast, but then it tries to compile the rest of the entire project before reporting them. That's fine. I still want to follow the red brick road. So let's go. Perfect. That's what I wanted. Declared here. Now I'm just going to go add node source. Okay, there we go. Token source, node source. Okay, now I should be able to... Oh, well, I need to do the same thing here. I like my new comment too. It can be a variable declaration or capture scope. Oh, that's a good point. Okay, so it might not be a variable declaration. It might be... Here's our example again. It could be a capture. It could be like, you know, if it could be this, and then it's an unused bar, in which case we want it to point to... In this case, I think we want it to point to here, actually, which is a little weird. Yeah, but that's right, though. Okay, I think we're gonna we'll handle captures in a second. Let's just try to do variable declarations first. We have plenty of yaks in our yak stack. We don't want to get a yak overflow. Okay. So this should give us errors telling us where we're not populating node source. A bunch of places, apparently. Oops. Yeah, right here. Okay, so we populate token source. Oh, this is a parameter. Okay, we're going to have to make these decisions. Crap. I kind of need like a placeholder, but this value is definitely going to be used, so... Okay, what node are we going to use for parameters? We need it to be the function body, I think. Is there a body? Oh, there it is. Wait, that might be really far away. Is there a body? Yes, it's right there. Okay, body node. Okay, next problem, 5524. Detect local shadowing. Oh, no, it's right here. Okay. Okay, what node are we going to use here? If expression. Oh, this is the thing I was talking about. So I think we want to use the body of the payload. Do we have that? Ooh, we do. It's the then expression. Hello, two-step. Welcome. Are we improving unused variables? Yeah. I think I'm gonna not repeat the whole intro because we had like a whole discussion about it, and it was I don't know. It can get a little bike sheddy, and now I want to try to actually do something. But to summarize, we're working on an auto fix feature which edits your code to so you opt in, and then it edits your code to add like a lint suppressing stuff, basically. Okay, where are we left? Oh, I should have just gone through all the errors. I don't know why I ran the compiler again. Oh well, it'll be done pretty soon here. I'll just scroll up to this one, 2851. Okay, where are we now? We're in variable declaration. Aha, this is the one that I was trying to target. Okay, in a variable declaration, I want the, well, this one, I think. Yeah, node. Simple enough. Okay, what's left? A few, not too many. Okay, where are we now? We're in if expression again. Hey. Oh, I see. So that's for Booleans. This is for like, oh, for error unions. Yeah. Okay. Next, 5859. Yeah, so the idea is if you don't, if you like status quo, good, then because that's staying. If you don't like it, then you turn this flag on, and people who still like status quo get to keep having their way, and you get to have faster iteration on your code. Okay, where are we doing now? It's token, node source. All right, where are we? We are in whiles. Okay, so I think this is the same thing. Is there a then expr? We'll have a cond expr. There it is. While full.ast.then expr. Are we almost done here? I think we're almost done. 2705. Here's another one. All right, where are we? We're in, ooh, defers. Oh yeah, it's defer with an error code. Yep, that's a use case too. Okay, so where's the expression? I think it's expr node. Oh boy, we got a bunch more. This is a big file. It's almost 12,000 lines. Okay, so where are we now? We're in, oh yeah, if and while also have an else expr. There it is, else node. Five, 9, 6, 6. Where are we here? While expr. Is this the else? Yeah. Else node. 6140. Okay, where are we now? 4 expr. Oh yeah, 4 expressions have else as well. That has a capture. Okay, so for the else of a for loop, I think we also have else node. Ooh, we don't have an else node. Okay, where's the else expression? Oh, this is the index. Right, okay. So we want the, oh, there's another one here too. Then subscope. Where's the expression? Cond expr. There it is. Oh, there it is. For full.ast.then expr. That's the index. That's the payload. Right. Okay. So for both of those, we're gonna put this one. Okay, and then for the else on the for loop. Oh, where's the else? Oh, there's no capture for the else on a for loop. Okay. Let's run this again. Okay, now we're on the else of, I don't know, it doesn't matter, but we have an else node here. Oh, wait. Oh. Oh, we're almost done. Okay, 5229. Where are we now? Oh, catch. Catch gives you an error. So in that case, the capture expression, here it is. It's RHS. Next, 6472. Okay, where are we? Looks like we're in a switch. Okay, and then where is this used? Case ast.target expr. Okay. What's next? Almost done. Last one. 2952. All right, where are we now? Oh, variable declarations again. Okay. Simple enough. Okay, I think that we have done it. Let's try and build it again. Oh, they were trying to do that. Interesting. That's news to me. I didn't know that. Oh, we missed one. Okay, so where are we here? Ah, we're in variable declarations again. Okay, well, it's same thing then. Same thing here. In this function, node is the variable declaration, so that'll make it nice and easy to put something after it. Okay, the problem is that I don't think that the AST is very amenable to being edited. Like if I just add a new node at the end, is that going to mess it up? Yeah, it is. Well, no, I can think of how to do it. I think we're going to be okay. Okay, well, we managed to compile the code. Let's run it again. Okay, we didn't manage to do any improvements, but now we have more data. And specifically, now that we're over here, we have this token which told us the identifier name, which is how we got this. But now it's also going to tell us the node of the whole variable declaration, which is going to tell us where we can insert some code. Okay. So now the question is, what are we going to pass to render? If we just pass this tree, which we have right here, we have a tree. If we just pass that to render, it's going to do zig format on it. And then we can rerun it ASTgen. That works fine. But we want to edit it first. So maybe we can try editing the AST before we call render. That's the idea. So here's the AST. Let's say that we have a variable declaration. Now it could be, well, it's going to be one of, I don't know. It could be any of these actually. Never mind global or local or whatever. And in this case, the data is stored in different ways. That doesn't matter because we don't need to access that. All we want to do is just put something after it. So I just did all this work, but now I'm realizing that that doesn't actually solve the problem because what I actually want is to put a new statement inside the block that contains the variable declaration. So that's what I actually want, which means I need to put different data here, actually. So this node is the variable declaration node, but what I actually want is, see this function is called from inside of block expr, boom. And what I actually want is the node of the block, which I guess is here, block node, which is actually not even passed to this function. Right there, it's missing. Oh wait, no, block scope has it. Or does it? No, it doesn't. Okay, but even if I had that information, man, editing the AST is so tricky. Oh, I wonder if the best way to solve this actually is with like an extra table of data, like fix-ups, like a fix-ups table that we give to the render function. And whenever the render function renders a variable declaration, it looks in the table and sees if it's supposed to insert something after that. That might be the most straightforward way to solve this problem. That way the AST can remain read-only, which is pretty nice. Man, mutating the AST sounds like it's a recipe for tricky debugging. That reminds me of what I do in zigwin32 bindings cogen. What do you do in zigwin32 bindings cogen? What does the render function do? The render function takes an abstract syntax tree and converts it to Zig source code. So for example, Zig format is implemented by parsing and then rendering. And that's the whole thing. Oh, I see. What about function args? Yeah, same thing. So the fix-ups table, it would have to have a way where whenever you're looking at, like at certain points, it would just check the fix-ups table and see if there's supposed to go a fix-up here. You know what I mean? I'm gonna start trying that because it seems I can imagine how that's gonna look from start to finish, and I think that's gonna be the key here. So, okay, let's say that I do that. Let's pretend that works, and let's figure out the next step. I think that's the biggest puzzle piece here. All right, so where are we at here? 1:30. I think I can keep going. I had enough lunch, feeling good. All right, tell you what, we're going to do another 30 minutes. And then if y'all are still interested in this topic, then I'm going to go make a fresh pot of tea. And then we're going to resume. We'll do another like hour and a half or so. But if it just gets kind of like a drag, then maybe I'll just call it. I feel like we're on a roll, though. I mean, we're making progress. These ideas seem like they're driving to an end here. Okay. So let's assume that I've successfully, we're going to add a new, let's see. No, we're not going to add something to AST. We're going to add a new function called render with fixups. Like this. And then these other functions are just going to call this one, obviously. And then fixups is going to be a function. This is just going to be hash map unmanaged. Oh, that's neat. I didn't know about this. Okay, so what's the key? What's the value? Oh, we need auto here as well. Okay, so the key is going to be a node index, and then the value is going to be whoops, fix up. And what is a fix up? This will probably change to a tagged union. But for now, we're just going to assume that a fix-up is always adding a discard for a variable declaration. Okay, so we'll do var decl node. And then you know, I guess that's all the information we need, right? Because it's obviously it's just going to be the same token as the name. So actually I did this thing, but I just didn't even need to do that, I think. All right, well, let's just let's leave that for now. Okay, now we need to go implement, well, render tree needs to, all right, render tree obviously needs to have this function added. And then these should be over here. Okay, yeah, we need to use this parameter, obviously. Oh, I see. I'm calling import here because I'm trying to have a function called render here. I see. You know what? I'm just not going to have this here. And I'll just call render directly. There. Okay, so what are we going to do with fix-ups? Let's try to implement this code. Auto-indenting stream, render. This is just doing... Wow, we're not even calling... we don't even have like a struct that we're messing with. It's just a bunch of functions. That's kind of cool. Okay. Oh man, that means we have to add a new parameter to every function though. That's a little daunting, I would say. Really? We don't have like a render struct? Okay. I guess that was my choice. Yeah, we're passing like the same parameters to everything here. Well, these make sense to be different. These make sense to be different. These should just all be in a struct. I bet you every function starts with GPA AIS tree. Let's find out. GPA AIS tree, AIS tree. Yep. 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 Okay. Well, how big is this file? Oh, it's only 2,800 lines. Okay, so that's fine. Let's just make a render struct for this. This is internal. AIS. And then tree. Oh, it's AST. Okay. What about buffer? Oh, this it just goes into the stream. Okay. I see. Render comments. Okay, so this is gonna go here. Close that for now. And what else we have? AIS. And then tree. We're gonna call that R in every function. I'm doing a big refactor here, but oh, this is gonna make it a lot nicer to maintain this code, so I'm fine with that. Okay, render comments is gonna take R. And is it read only? Yeah, it's read only. So I can just pass it, no problem. Okay, there's that one, that one. Okay, there's this one. Okay, this everywhere. This is going to be replaced with this. Okay, that wasn't too many places. Okay, we're going to have a bunch of errors now, though. There. Fix-ups, right. Okay, so now we want to put fix-ups in here. Render member. Okay, so now also, yeah, let's change these. Render extra new line. Yeah, let's give this one the thingy too. This one too. Oh boy. I didn't think I was going to have to do this on the stream. Okay, I think there's a lot of these. Oh, that was the last one. Damn it. Okay, what's next? Tree. Okay, so we'll add that. Okay, I know there's a lot of render tokens. Okay, should I just do regex for this one? Maybe. Okay, I think I should do regex for this one. All right, so let's do everywhere render token AS3 token. Looks good. Next. Oh, no. I got a better idea. Okay, get rid of all these r.trees. There we go. Okay, same thing here. We're just going to grab it at the beginning. Okay, render expression. I think I need a regex here as well. Looks good. Next, GPA. Render block. Oh man, it's gonna take a while just to type all this out. I have to edit all these lines regardless though, because if I didn't do this, I would have to add another parameter to everything here. Oops. Okay, let's try. What about this? I'm gonna search for parentheses GPA AS tree comma underscore or comma space. Okay, if we find this pattern, we just do this. The power of uniform code. It'd be awesome if there was a refactoring tool that could just do this for me. People who use like Eclipse and stuff, people who like Java users have this ability. Okay, let me try and see if a macro will work here. So I'm gonna search for this, and then I'm gonna notice if it looks like this, and if it does, I'm gonna do this. Actually, maybe just dot will work. Yeah, okay. Dot is doing great for me. That's it. Okay. Now it's gonna complain about all this stuff, and I'll just add these here. There, now I just add all these to all my functions. And then if it says unused, then I'll just delete it. I just don't have two clipboards, that's the problem. Ah. Well, we're at 76%. That's not bad. Yo, look at that. I got rid of all that. And voila, we now have the ability to add a new piece of state that every function has access to, which is now called fixups, without some kind of, I don't know, secret context parameter. And that, my friends, is why unused variables and those other errors that you saw popping up are super useful when refactoring. Holy shit. Let's go. Okay, but I think there's probably errors. Let's look at the errors later. Let's take a break from typing and start using our brains again. So we added fixups. This is my idea. Now, the nice thing about this is if this idea is bad and I delete fixups, we can still keep our refactor, which gives us the ability to experiment with this renderer more with adding or removing fields. So it wasn't a waste of time, even if we back out of this idea. So that's nice. Okay, but what is the idea? The idea is that we have these fixups, and they're available here. And if we see it, we do it while we're rendering. So let's find the place where we're rendering a var decal or something. Okay, there's 4 places. Oh no, we put them all into one. Beautiful. Love that. So happy. Okay, now after we render the variable declaration, we're going to look for a fixup. Okay, now we do need to edit this code because there's more than one return location, but we need to have code run after the return. You know what? Okay, I know what to do. We're going to rename this to render var decal without fixups. And then we'll have the real render var decal, call it ta-da. Okay, but actually, oh, there's no results. So we just do it and then look for fixups. Okay, so this is a table. What is an ast.full.var decal? Oh, here it is. Okay, so if we have visib token. Ooh, ast components. Moot type node. But okay, but what about the actual node? I think we're missing something here. Holy shit, I just thought of something. With this strategy, we don't actually need all that extra work I just did in ASTgen where we're populating the source node. I could actually revert all of this. I'll leave it for now, but I'm going to actually not depend on it yet in case we don't need to depend on it. So as a reminder... Oh, wait a minute. I see a problem here. Okay, we thought that 0 node wasn't being used, but it was, because look, when the node is not 0, it's now underlining this instead of underlining this. I see. Okay, fine. All right, so I'm a couple yaks deep at this point, but I can get out of it really fast. You're not going to believe how fast I'm going to shave these yaks. Okay, you ready? First, yak number 1. What are all the changes to ASTgen? Okay, I found them all. Here's what we're going to do. We're just going to copy ASTgen to the temp directory. Ta-da! And I'm going to revert it. Okay, reverted. ASTgen is now how it was before we started the stream. Okay, we're not going to look at... we're not going to look at the node. We're only going to look at the token, which, as a reminder, is what we wanted our... Keep going. It's too far up. Point being... simpler change. The fix-up strategy is nice and simple because all we gotta do is look at the token. Token's gonna point here at that token. So when we're doing our fix-ups, render deck, blah, 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 we already have this thingy, and this thingy tells us the ident token. Where's the ident token? Does it really not tell us the ident token? Okay, there's the moot token. I guess we just do moot token +1. Yo, what's up, mlog0? We are implementing an autofix feature. It's going to autofix your code if you see this problem. Right, okay. Next yak is this one. So it's not a var decal node. It's actually going to be a var decal, I don't know, moot token. No, I'm not solving the halting problem real quick, but I'm shaving a bunch of yaks real quick. Okay, next. Fix-ups. We only have one kind of fix-up so far. This will probably be a tagged union, but Yagni. We'll keep it like this for now. Okay, so we get the fix-ups. Now, we know that we're looking for... Oh, wait, it's a node index here. Okay, let me not get ahead of myself now. But let's also not get confused. So fixups is a struct, unused var decals. Okay, so this is actually just a hash map with no value, just a key. We'll get to those in a minute. So all you gotta do, oh, and it's tokens. So token index. Okay. The key is the key is what? I guess it's the moot token. Okay, there we go. I should have that inserted afterwards. Okay, oops, I have some half-written code here. So, there we go. Now, we might consider, you know, changing fix-ups to be, I don't know, an optional pointer so we don't waste memory, blah, blah, blah. It doesn't matter. Let's just leave it like this for now. These can be empty. If they're empty, then there'll be nothing in the table. That'll be nice and quick. Okay, so we're checking the unused var decals. And we're looking for, what is it, just get? I think it's just get. Ooh, I should use the new auto docs. Yo, is Laura still here? I hope he's sleeping by now. But let's try it out. Yo, look what I'm doing. Okay, so we have this open. Now we don't have to wait for it to load anymore. Let's give it a little bump. Hash map. Not array hash map. How about auto hash map? Ooh, that's nice. Okay. I want to know how to get something. Ooh, should I search for get? Hash map get. Yo. Okay. There it is. Oh, this is a nice experience. Holy shit. This just like leveled up my development experience. I don't even need to read the source code anymore. Who needs source code? Okay, and it's an optional, and it's the key. Okay. That was a nice experience. I love that. I mean, look at this. Boom. Search. Hash map. Get. That one. I love it. That's like very quick. Okay, so we get it, and then right. So the key is the moot token. So we need the moot token. Var decal dots. Yeah. Now I want, like, you know how this one's for standard library. Now I want one for you know, like the zig compiler stuff. Oh wait, this is in the standard library. All right, let me try this. Full AST moot. Oh, it doesn't do struct fields yet, I think. Okay. Var decal? Pretty good. Well, okay. I have this one open, so I'm just gonna use this one. But yeah, this is leveling up my dev experience. I'm very pleased right now. Okay. Varticles. Yeah, I got breakfast in bed this time. Let's go. I love it. Okay, so moot token. Where's moot token? It's here. Components. AST.moot token. Okay. I think that's it. Full.vardecal.ast. Yeah, moot token. Okay, there we go. And that's going to return an optional. So if, and then what is this? Oh, we're just checking if it contains, actually. So we need to go back. Hash map contains. Is it this one? Oh, great. Okay, so yeah, it's a bool key. Yeah, wow, this is nice. Check if the map contains a key. Yeah, that's what I want. Okay, so this is real simple. It only stores, you just check. If it has the key, you do the thing. I think this is going to be a good way to go. Okay, but now we have to do the work of checking. We have to get the name. Anyway, okay, it's fine. We just basically just do this thing, but for render something like this. Discard variable this. There, okay. So now we can just follow the pattern here. Now, the difference is that in this function, we are rendering tokens that exist in the source code, and they may have comments before them, after them, that kind of thing. Here, we're just making shit up. These tokens do not exist in the source code. So we need to reach a little deeper. We can't call render token. We don't have a token to render. We just want to render literally an underscore and an equal sign and some spaces. So we want to reach directly into the stream like this. And what is AIS? Auto indenting stream? Do I get like a writer? Yeah, there, that's it. Well, it's called auto indenting stream, so I'll be damned if I have to manually indent. I'm going to call that someone else's bug if I was supposed to manually indent with the auto indenting stream. Okay, I think that part's done. So maybe we just try to figure out the... all we got to do is figure out the token name, or the... what is it called? Yeah, right here, the name. Okay. Moot token +1. Oh, that's super easy. Okay. Now, I got to be careful here because I can't call render token because this is going to like re-render comments or some weird stuff like that. So I need to actually just extract the name. So I need to go a little lower level than this. I need to see what render token does. Oh, here we go. Token slice for render. Oh, well, that's extremely straightforward. Storyteller Moxad is saying that the A actually stands for Andrew, why didn't you? Oh, that's funny. Oh, man. I swear to God, if this auto-indenting stream does not auto-indent. Okay, so we don't want to do this, but we do want... This is the token index. I mean, hell, I'll just throw it right in there. Okay, what's wrong? What did I do wrong? Okay, you happy now? There we go. Wow, I think this fix-ups is the way to go. Leave the, holy, I can't even believe I was considering mutating the AST. That is insane. Okay. This is so straightforward. Just like attach some extra data that gets used. Didn't even have to touch this function. All I had to do is rename it. It's amazing. Okay. Think we're actually looking pretty good. There's a discard. And then the fix-up only happens if there's an error. Okay, there we go. So now we have the capability to render with fix-ups. And so this code just needs to now, okay, we still have a couple more puzzle pieces, but I feel like we solved the hard ones. So now the puzzle pieces left are create the fix-ups. We're just going to do one for now here. Well, I guess there could be more than one of these errors. So we'll create the fix-ups, and then if there are any fix-ups down here, is not 0 or access greater than 0. Same thing for unsigned integers. Creates, do some backflips and then realize you could use a sticky note. Yeah. Yeah. Okay. Right, so then here we'll do the render and then go back and redo this function again. And then hopefully we don't get into some kind of endless loop where the fix-up doesn't actually end up getting rid of the error, and so it just goes into an endless loop trying to fix it and then failing, and then the file just keeps growing and growing and growing. So we'll look out for that error. Yeah, well, I appreciate the nice comment, but let's look, give it a try. when it's ready, and then we'll decide if the user experience is improved or if it's a bad idea. Okay. So far so good. We're almost there. So there's these two things to figure out, and then there's add the fix-ups to a table. So let's create a fix-ups table. We have a, where's our type here? Render. Excuse me. You know what? I'm just going to import it right here. Standard.zig. Oh, wait. Maybe I could do this. Stand.zig render. No? No. Render. Ooh, it is ast.render. Okay. Wow, this search is super nice. Okay. So we have ast already. Oh, so I don't need to import this then. It's ast.render. Okay. Okay, but what's the fix-ups though? Render.zig. Oh, I see. So we have public stuff here, but then it's not really exposed. So it should be ast.fixups, I think. And I should add a function here, I think. Yeah, I think I should. Because this is private and this is public. So I need to expose this stuff. This can stay public here, but we need to like re-expose it. Okay. I'll do it in a sloppy way. It's like private sloppy, but public clean. Yeah. And then maybe we can clean this up. Cleaning the streets, spaghetti in the sheets. Yeah, that's what we're doing with our like import thing here. Although there's a really easy way to solve this problem. Here we go. There, easy. I just invented a new convention. Done. There. I'm gonna sneeze. Excuse me. Okay, that part's done. Oh, let's oh, wait a minute. Let's just press save. Unused function parameter. Oops. There we go. Oh. Okay. That's such a funny little microcosm of what we're all doing here. Okay, so render with fixups, that's our public function. We got that there. So it's ast.fixups. Okay. There. Now, because we used, it used to be that, let me just explain this for a second. I want to point out that we're using, where is fixups? Here it is. We're using auto hash map unmanaged. What does unmanaged mean? Well, the normal one that doesn't have unmanaged has an allocator as one of the fields. And that seemed like pretty handy. But I'm actually leaning towards maybe making this one the normal one and having managed be the one that has the allocator or maybe calling it something else, because man, the ones that don't store an allocator are just so damn handy, because you don't have to, you can default initialize them and they start out empty, which is really handy. So I feel like these are almost more, I like counterintuitively, the unmanaged ones are almost more useful, even though they don't store an allocator for you. And it also encourages you to do the like thing where you reserve capacity and then start using it. Yeah, see? Supak knows what's up. Not const qualifier. That's I think Red Candy Eater is trying to go for one of these. You know, I did it with multi-array list, and no one has complained. Everyone likes multi-array list. No allocator. There's not even a managed version of it, of multi-array list. Okay, where were we? I think we're over here. No, we're over here. Right, so I just created this. The hash map is in there, and it's empty. Now we need to add an entry. Okay, so let's review the hash map. The key is the moot token. Yeah, moot token of the variable declaration. Okay, but here's the problem. I'm just getting distracted by these codes looking like kind of similar. Let's just close this one. Okay, let's keep in mind though that the token we actually have is the identifier. Where is the identifier token? Here. This is the identifier, not the moot token. But it is a fact that in Zig, if you add 1 from the moot token, you always get the identifier token. And if you subtract 1 from the identifier token, you always get the moot token. So that means that we can do this. Unused var decals. And we can add 1. Ooh, what is the put API? This one. Ooh, wait a minute. No, it's the unmanaged one. There we go. Right. Okay. Wow, this docs are very nice. This is extremely usable. Oh, I can click this too? No, I can't click it though. Okay, well that's to do, I suppose. Okay. Key value. Right, so allocator key value and then no return. And we have, well, that's not no return, it's void. Okay, yeah. So that can fail. Obviously, I'm pretty sure we're allowed to fail from this context. Yeah, that's fine. Okay, okay, we need the allocator, which is, oh, yeah, who owns this memory? It's read-only, so this place owns the memory. So where's our GPA? There it is. I could have just typed it. There's that one. So let's put a fix-ups. We'll give them a dinit function. Okay, so that makes that just a single function call. That's nice. And then what are we putting here? Okay, so the key and then the value is going to be void. Easy. So the key is the moot token. And then the moot token is data token plus. No, this is the identifier token. Here, let's actually give that a nice name. It's the ident token See this, now it's obvious this math is wrong. There we go, -1. So we go from here, -1 to the moot token, and this is the moot token. Okay. Okay, we have requested our fix up. Unused local constant, yes, okay. Okay, great, we added our fix up. Now what? Now we need to do a render and then go back and redo the function. Okay, 2 more puzzle pieces, and then we can give it a spin. We can take it for a drive. Okay, so render. We need to call tree. Where's our tree? File.tree dot render with fixups. Okay, we need a buffer. I guess we'll just create one. So here's a place where we use a normal array list, which has an allocator, because we wanted an allocator in it, but we could have passed it separately too. So I don't know. Anyway, so the sorry. There we go. And fixups is read only. Wait a minute, where is it rendering to? Oh, to the buffer. Okay, so we have a buffer. I don't think I even need a comment. This is like pretty clear what's happening in these 3 lines here. Source, let's call it something useful though. Fixed source. Okay, there. That's pretty clear what that is. Now we need to go back and redo the function again. Well, we need to write it to the file. And if we fail to write to the file, then it fails, because you don't get to do it unless it succeeds. And then we need to repeat these steps. And this step. So here's a question. Well, if the parse fails, then we're going to bail out earlier. So that makes sense. Okay, but here's a question. What if there's some errors that can be fixed up, but others cannot? I think that autofix should only trigger if all of the ASTgen errors are autofixable errors. I think that if we get to here and this line was triggered at all because there's errors that cannot be autofixed, then it should abort mission, don't autofix it until the non-autofixable errors are gone. What do you think about that? I think that's right. Could be like a little confusing if there's a lot of auto-fixable errors and then the one that you need to fix is buried. We could, you're in half fixed state. We could also just suppress the error if that situation happens where you asked for autofix and then there's both autofixable errors and not autofixable errors, then we suppress the autofixable errors and only show you the non-autofixable errors. Yeah, that's the move. That's the move. Okay, one thing at a time, but I'm absolutely sure that's where we need to get to. So that way you only see the ones that you must fix, and then once those are fixed, then the autofix kicks in. There you go. Yeah, that's the way to go. Okay. Right. So go back and redo this function again. Okay, we're down to 1 puzzle piece left, and then it's time to just iterate and enhance. But one more until we can take it for a spin. Okay, so we need to write this to the file system. And never mind my thought, as a half-formed thought. So we have a new source, but obviously we can't just replace file.source with new source. We need to write it to the file system. Okay, so I guess the first question is, how far back in this function do we need to go? I think we can skip the cache check. Obviously, it's not cached. We just edited the file. So I think we go back to here. File.zir loaded. And not has... Oh, I see. File.unload. Stat.size. Stat came from before. That came from checking the cache. Okay. So this is a little, we have to be a little careful because we're going to have two kind of control flow points here. One control flow is going to come from cache miss, and the other control flow is going to come from autofix. Because here we're checking the stat size. Here, file too big. Okay, well that's fine. Allocate. Oh, and here we're reading from the file. Okay, I'd like to do something a little clever here, which is that we write the file, but then if it succeeds, we don't bother reading from the file. Obviously, we have the contents. We just wrote the file. So let's skip this part. And let's go... Well, source loaded. That's all true. Tree, parse. Okay, we do want to parse it again. I'm pretty sure we want to go straight to here. This is the point. Okay. Let's call this, let's make it a label, just to make it very explicit. And I'm going to call this, I don't know, let's call it parse. Now, okay, I'm saying this is while true, but I basically want to make it just one loop possible. And if we loop again, I basically just want to assert that it only loops once. That's an interesting question. How do you do that? I mean, obviously I can just have like, you know, a flag. I think that's the way to go. Okay, there we go. So I just have reparsing is false. This is purely to detect when a compiler itself has a bug, and when the auto fixing has a bug and the auto fix did not make the compile error go away. Yeah, I think that's the move. So while true, reparsing is false. Okay, here we go. So we do that. Go back and redo the thing again. Okay, so let's do reparsing equals true. Continue parse. Okay, we're gonna need to think about this a little harder. Let's come back to that in just a second. And then here we're gonna do break parse. No. I need to add another end curly. I think here. Okay. And then here, we're going to assert reparsing is there. Yeah, we're going to assert that we're not reparsing, because if we get here, or let me just explain it. Autofix failed to autofix still, there are still compile errors after autofixing. There. Get rid of the while true. Wait, how do we get rid of the while true? We have to go back up to the top right here. So we do need a loop. The whole point of reparsing is just for this assertion right here. That's all. Okay. Okay, we need to do more work here though. Okay, so we have the auto-fixed source. We need to care about updating some stuff. So let's go back up and inspect what's happening before the point that we jump back into. Okay, source needs to be updated. Now we also need to not reference this source anymore. We need to reference it from file. So let's go make sure that that is true. So let's take that one out. Does file have a source too? Oh, it does. Okay. I think we're out of the function at this point. Okay. All right, I've made sure that we're using file.source now. I should probably name this something a little trickier so that it doesn't get abused. Or I could make it a var. If not, file.source loaded. So when we set source loaded to true, then we keep it there. Okay. Okay, here's the problem. I want to free, not file.source loaded, but we set it to true here. Okay, yeah, this is fine actually. So we're going to take this source code and we're going to make this be it, but we need to free the other one first. So what I'm going to do is file.source. Let's free this one. And then we can change it to the auto-fixed source. So if anyone's sleeping on me, here, watch this, because this is a handy function on ArrayList that you might not know about. toOwnedSlice. So what this does is it converts your ArrayList to a slice, and it sets it to empty strings so that this defer is still good to go. And now the ownership is now transferring to here. It's pretty handy. Yeah, literally, it's basically move semantics. Yeah. Okay. So I think that's good. The stat needs to change. Otherwise, the cache is going to have a false negative. Okay, let's obtain the stat when we... Oh, here we go. Source file that read all. What is this? Ooh, source file. Open file. We have an open file. Okay. I can work with this. Okay, let's try to overwrite the file. We have the file open. That's brilliant. Okay, problem though. Open file. We didn't ask for write ability. I think we could do that right here. So open file. How do we ask for write ability? Ooh, maybe the docs will tell me. Open file flags. Ooh, let me just click this and find out. Oof, okay. Not quite. File.open flags. Okay, I can search though. Open flags. There it is. Ooh, this is handy. Lock. No. Open mode. What is open mode? Okay. Well, since I can't click, I'm going to just use standard library. Okay, we got open mode. Okay, read only, write only, read write. Okay, I see, I see. So let's do, I see, this is gonna be fun. Watch this. Open flags equals okay, if autofix. Oh, wait a minute. No. It's going to be even more fun. So we need to bring some of this other logic up too. From here. There's a lot of interesting components to this. This one. Want autofix is going to be what this is called. Okay. Doing good. So if want autofix, then the open flags are read write. Otherwise, they're read only. So if you get error read only file, it's your own damn fault for asking for autofix. Okay. Dot mode. Okay, so we now have the file in read-write mode under these circumstances, which means we can do this. And we're going to overwrite the source file on disk with one syscall, which is pwrites, I think. Yeah. Yeah. Let's do this. So we have the file open. Awesome. We don't even have to close the file. We just still have it open. And then... Oh, wait. Let's try to go here. Oh, wait. No, let's click this. p right all. Nice. Okay, there it is. File, bytes, offset, and then we have a possible error. Perfect. Bytes is okay, I guess we'll just do this one first so that we have a slice. Offset 0. Done. Well, that was extremely straightforward. Holy shit, is this it? Okay, so if there's any fix-ups, then we render the code. Replace the file source with the fixed-up source. Overwrite the source file on disk. And then go back to the parse area. Okay, let's go review. So this is now fine. Oh, the stat. Don't forget the stat. Ooh. We also need to truncate the file. If the fixed up source is smaller in bytes, then we need to truncate the file. Oh, we don't have truncate? Is it like set end? Oh, there it is. Set end pause. Okay. This dot comment should have the word truncate in it. I could just do that right now. Shrinks or expands the file. Truncating. I don't know. I'll think about how to reword this later. Shrink. It'd be nice to have both the word shrink and truncate in the doc comments. You know what? People are watching. Let's set a good example. Yeah, good enough. Set end pause. File length. Okay. It'd be great to have an API where you do both of these things and then get the system to do it at the same time. I think with IOU ring you can do it. It'd be nice to make like a I don't know, multiple syscall abstraction. File.set end pause. Yeah, okay, so the length. If the file size is less than the fixed up one, then we need to do this. Otherwise the p write all would have done it. Okay, what is the length? File.source. No. If it's old size is greater than new size, then we need to truncate to the new size. Okay, I feel like there was one more thing that we needed to do. Oh, and then we need to redo the stat. Right, okay, so then let's, right here. Coffee before code. Hello. Unused variable should be a warning, blah, blah, blah. Okay, so we had a whole discussion at the beginning of the stream that you missed, and we definitely addressed this. This position was represented. So, I don't know. Maybe watch the recording later and see what you think about the discussion, and then play with this feature that I'm implementing right now. Okay, so now we need to redo the stat so that the next time we hit the cache, next time we get a cache hit. All right, what did I forget? Okay, I think we dotted all the I's, crossed all the T's, and ready to find out what's left. Let me scroll up one more time up here and see what we're missing. Okay, so this is where we're going to repeat the while loop. So let's make sure all this stuff looks good. We redid this stuff. Redid this stuff. We're not touching this variable anymore. Not touching this variable anymore. I think we're good. Okay, let's see what's wrong. Probably something with our the big refactor we did. So 3, 4, 8. Oh, that's an interesting place to complain about this problem. Expected type open flags. Okay, well, I'll make a mental note of that being unhelpful, but I do know where that's talking about. I think that's good enough. Okay, next problem. Render 29. Expected type found function type. Oh no. Is that why I was passing it as a parameter? No, this should be fine. Fun type. Oh, it is a wait a minute. Something's weird. Oh, there's like a different type here. Okay, I just typed the wrong thing. Whew, my bad. Okay, I didn't get interfaced. It was literally a typo. I typed in this instead of this. My bad. Ooh. Yeah. Okay, next problem. 3497 in module 3497. Open flags dot read write. Really? Oh, open mode. Okay, next problem was Render 43. Well, it didn't coerce them because, I mean, it was a function that returned a type instead of a concrete type, which is what I was trying to. I mean, I passed this instead of this, so it makes sense that it didn't coerce. Type. Oh, oops. I'm making all kinds of typos here. Oh, the enum literal? Oh, yeah, maybe it would coerce them, actually. Let's try. I'll give it a shot. Okay, but let's see what's next. So, 497. Open flags. Oh my goodness. There. Okay, render expected 2360. Under space. Just following the red brick road here. Oh yeah, looks like that did work now that I got the type correct. Oh, no function named count. Oh, fixups dot. You know what? I'm gonna add another utility method here. Why not? Okay, next. 1198 under token comma. All right, 1810 under expression. Okay, I guess there's some calls to render expression. Oh no, I think oh fuck. I might have made a change that should not have happened. Okay, I see. 1810. Okay, so here's the problem. We're making like a sub stream here. Even though we have one in scope here, it should not be used. Instead, this one should be used. Which is still fine with the way we did it, but I'm wondering if I messed it up. Crap. Okay, I'll have to examine the diff and look for that problem. I need to run the zig format test suite before we can take this code for a spin in case I mess things up with my refactor. So anyway, to fix this, hopefully that was it. How are we doing here? Ooh, coming up on 3 hours. It's kind of a long stream. I feel like it's been going pretty well though. Okay, this is an interesting error. To own slice. Okay, I think we have a sentinel. Nice. Oh wait, I think this one can return an error. Yeah, it can. Okay, so that's fine. Because we have to possibly add a Oh wait, no, I need to make the slice happen up here. I just want to care about the ownership a little bit here. So if this fails, we don't do this. That's good. But if it succeeds, then we do this, and now everything's great. So let's do it like this. Okay. Was that just for me forgetting the try? Yeah, it was right there. Okay, we're good. So the nice thing about the way that this is implemented is that this code is in fact run on the thread pool. And so we're not, even people who love this feature and keep it on are going to enjoy fast compilation. It's going to do all the fix-ups on different threads. It interacts with the cache correctly. It's not just like another pre-processing step we're just throwing on there before everything. It's integrated. So it's it's a first-class citizen. The feature is not, it's not bullshit, you know. This is the kind of code that just makes me so excited, like in Zig, you know. It's like you can watch this happening with strace, and you can see that it's using the minimal number of syscalls to do the job. That makes me excited. Okay, so no p write all in module.file. Oh, I thought this was a. Oh, okay. This is this kind of file, not a OS file. Okay, do we have an OS file? I think we do not have an OS file open. Wait, no, we do, because I was just passing open flags. Open mode. Right here. Handle open file. Source file. Okay. Source file. There. Okay, 3848. Set and pause. Right, I'm getting file and source file confused again. Okay. Oh man, I told myself I was gonna get some more tea at 2 hours, but then I totally forgot. Now my tea is cold. Again. There we go. Okay. I think we can take it for a spin now. See how it goes. Now we do have to clear the cache because we're messing with stuff that's cached, and then we're not changing the Zig version in between runs, which makes sense. So we do that, and then okay, here we go. We're taking it for a spin. Now let's see what this file looks like. It looks like this. If you try to compile this without autofix, actually let's. Oh, that's a good point too. Just realized that if you try to compile it without autofix and then you add autofix, the caching mechanism will skip all this logic. So we'll go address that in a second. So let's not trigger that. Let's do this. Requesting fix up for unused local constant mem. Yo, look at that. It worked. Pretty sweet. We got a new error. Error is ignored. Do you think autofix should should autofix also fix this one too? Just ignore your errors for you? Oh man. Maybe it should. I don't know. Well, that's a proof of concept, and that works. I'm going to demonstrate the other problem that I just thought of. So I'll clear the cache. We'll revert this to the same problem. Now I'm going to run it without autofix. There you go. Get the problem. And now if I run it with autofix, I think we're going to see the error again. Because in this case, the logic never makes it here. We actually cached the parsing and ZIR lowering. We cached a lot of stuff. And so we didn't have to do, we didn't even look at the source code. We didn't even load the source code from disk the second time, which is pretty cool. But anyway, point being, it's fine. If all we have to do is if we get a cache hit, if we get a cache hit and there's and we want autofix, then we just treat it as a cache miss. Like right here, I could just do that. Let's just add that real quick because I think that's going to be a fun demo, more interesting demo than before. So let's bring this want autofix a little higher up. Oh, it's right here at the top. Okay, so we already have that in scope. So here's cache. Here's a cache miss. Want autofix and there's compile errors. We do a cache miss because autofix is on. Doesn't overwriting the file invalidate the cache? You mean when I like saved it right here? I'm not sure I understand what you're asking. So in this example, I ran this command, and then all it did is change this flag, and I ran this command. At no point was the file ever overwritten in this situation here. So the problem is that even this compile error is part of the cache. But that's fine. So here it is. If you want an autofix and there's compile errors, so if you get a cache hit, but you want autofix on and there's compile errors, then we just go to cache miss. That's it. Easy. Now we might want to add a little bit more logic, like maybe we want like has, like auto fixable compile errors. Yeah, like we can make that change, but one step at a time. Let's go make this improvement. Oh, and by the way, these are this is without LLVM right here. We've been testing without LLVM. So I think Jacob's not watching the stream anymore, but kudos to Jacob for making this x86 backend good enough that we can do these tests without LLVM. Yeah, I think it's like pretty late in Poland, and he's got a kid, so he's got stuff to do. I think this is gonna make for a nice little demo here. Okay, let's try it out. So first, I'm gonna clear the cache, so we can start fresh. Next, we're gonna just show the code. So here's our example. Then we run build exe. Error, unused local constant. Next, auto fix. Oh no, it's a seg fault. Okay, don't panic, we can fix this. Wait, it's a seg fault, and then did we actually change it? No. Okay, so what's going on here? Return code.extra. Oh, I think I'm reading something before we... Oh. Yeah, this makes sense. We didn't initialize this yet. We're about to load from the cache right here. So we get a cache hit, but we need to actually load the ZIR. Like, we didn't even get it yet. It's right here. Jeez. Slow down. Okay, so we load from the cache. Okay, so here's what we're normally doing if we find errors in the cached one. Can you cache whether autofix was enabled when the data was produced, then only recompile it if it changes from disabled to disabled? That way you could avoid recompiling everything all the time when using autofix. So we would put autofix as part of the cache manifest. That is possible. It would double up the amount we'd be storing, though, if you were using it on and off, which doesn't seem necessary. Let me just examine this a little bit more, but I mean, we could do this. That would be possible. Yeah. Okay, so we load the ZIR. And then this flag decides whether we keep it or not. Yes. File.stat. ZIR loaded and not has compile errors. Unload and then load again. Yeah, the thing is, we don't want to just do a cache miss. We want to actually... We want something a little different in this case. We have reparsing here. Yeah, what's up, Zero, Z Shadow? We're actually towards the end of the stream here, but we almost have like a pretty fun demo going here. I just need to integrate slightly better with the cache system so that you can run it without the flag, then add the flag, and then have it interact with the cache properly. So it's not enough just to do this because we need to load the ZIR. Once we load the ZIR, now what? Let me see what happens in theory here. If autofix is requested, wait, let me think about this again. So if we did this, then Yeah, the problem is it would do a lot of recompiling that's unnecessary. I think integrating with the cache is the better move. I think that's going to ultimately save the most processing. So if the autofix is requested, what we need is like has auto-fixable errors, but we'll get there. We'll get there. Treat this as a cache miss so that the autofix code has a chance to run. Success ZIR. What is the file status before this point? Aha, okay. Wait a minute. Never loaded, retriable failure. If it's a parse failure, an ASTgen failure, or a success ZIR, then we look for unchanged metadata. Wait, where do we break from cached here? Unchanged metadata. Okay. I think we need the same logic down here too. No. Success ZIR. ASTgen failure. Right. Okay, if we get here, there's no fix ups to do. It's a perfect cache. We're done. We're only going to get here if compile errors are possible. Where do we look for? Oh, ASTgen failure. Oh, no. Here we do. Here we would want to check for fix. Okay, I see. ASTgen failure. Well, then how did we get to this point up here? Oh, because we checked. I see. Why did we get to here? Never loaded? No. Oh, yeah, it still would have been never loaded. I see. Okay, yeah, I get it. This has to do with incremental updates. Okay, I'm on the right page. Now, there's still more to do, but now I understand what's going on here. And if we break from cached here, success ZIR. It's not successful. So we can check for ASTgen failure, because that's the only time that we would be there. Now we're loading the source again. No, we have to do that. Okay, I think this is actually good. So let's give this another try. So the reason this segfault happened before is that I read a field that wasn't even initialized yet because I tried to check something before we even computed it. Okay, hopefully we're going to have a nice demo here to end with, and then the stream will be done. Then it's not ready to use. It needs to be polished a little bit, but it'll be a proof of concept. We'll have something to talk about, and we'll be able to do a little bit more work on it, polish it up, and then we'll be able to give it up. We'll be able to put it in master branch for people to try out. Then we can discuss if we like it or not. But let's see if our little proof of concept will work. So to redo the example. First, we're going to look at there. Okay, we have an unused variable. We do it without autofix. We get the error. Now, you can see how that wasn't instant, right? It's because we didn't only do parsing, tokenization, ASCII for this file. We did it for the entire standard library. It was pretty fast, and it's all cached now. And if we do this again, it'll be fast. Like, there you go. Now we're gonna add autofix. Okay, great. I think this actually worked. So these are memory leaks, and we've been not seeing memory leaks because I've been testing with the LVM build, which is not using this helpful allocator that shows you leaks. But yeah, it did in fact work. Now, is this leak easy? What is this pointing to? It's pointing to nothing. This is wild. Okay, well, that's a separate problem to be fixed. Maybe this is our fault. Okay, I want to solve this later. Let me do an actual real build here. So I'm going to enable LVM. I'm not quite ready to prime time this build yet, as you can see. And let's get rid of the debug prints. Huh. We don't even need this. Amazing. Unused. 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 There we go. So this will take a little longer. These are going to go away. And then we're going to get rid of this, and then we'll have our little demo. We should also change the example to, I don't know, print hello world or something. We didn't do with parameters yet. We only did it with variable declarations. We have to go edit render. So we did one place where we did var_decl. So here you can see var_decl has this logic here. So we need to add similar logic to this for parameters, other types of captures, all that sort of stuff. Okay, let's try our little demo again. Let's see if we can end on a high note here. So we have this. We have, let's clear my cache. Okay, so then we do build exe. Okay, wait, problem. I want to prove that this doesn't exist, but I already had a file here called test. So let's get rid of this. There. So let's repeat this again. Clear the cache, go back to cat. Okay, we're gonna do this one. Then we're gonna do this one. Then I'm gonna show that it did not make the binary. Then we're gonna do autofix. And it did do the binary. And there you go. We did it. 319. Gotta love it. It's a pretty hackable code base, I gotta say. So this is not shippable. There's a lot more polish that needs to be done before I'm willing to put this in the main branch. But this hopefully should give people the idea of where I want to go with this, how I want to experiment. And if everybody likes it, great. If people don't like it, then let's talk about that after we play with it and decide for ourselves if we like it. Okay? And then also someone on the stream earlier mentioned maybe it would be nice if it would add a comment here that says, like autofix, so that it's just you can notice which ones got in there automatically. Okay, we can talk about that. And if we did that, then that would go, that would just go right here. It'd be super easy, right? You just edit a string literal, so no big deal. So you get the idea. Hopefully this helps communicate what I'm thinking, and we can iterate on this idea. So let me just take a little screenshot. I'll put that on Twitter later. There we go. Andrew, how are you going to react when you one day start looking at the compiler source code and see an autofix in there? I'm immediately going to do git blame and see who did it. That's what's going to happen. And then I'm going to secretly, just going to judge that person. But then I'll smile and be nice in person. That's what I'm going to do. And then if I find out it was me, I'll be like, "Wah!" Oh, man. All right, well, I hope you all had fun. I think that's going to be the end of the stream today. And let's see, what's going on? Are we going to have another stream next Friday? Yeah, I think we'll have another stream next Friday. So I will see you all next week. And hope you have a nice rest of the whatever the hell is at your time zone. So I'm going to call the recording here.